Good morning. Today, let's know about the well-known chemical name reaction, Michael addition reaction. This reaction was given by the scientist Michael in the 1887. According to the definition, addition of the conjugated nucleophiles to electrophilic alkenes such as the alpha-beta unsaturated esters, ketones or nitriles in the presence of base gives high yield of monoalkylated carbonyl compound. This reaction is known as the Michael addition reaction. Friends, this is the simple type of addition reaction of nucleophiles and electrophiles. Here our nucleophiles are conjugated and our electrophiles are alpha beta unsaturated. So first of all we should know that what is the alpha beta unsaturated carbonyl compound. Let's consider an example. This compound is known as the alpha beta unsaturated ester compound. Here, this is the ester functional group. The carbon beside the functional group, first one carbon is called alpha, second one is called beta. Friends, see here double bond is present for the alpha and beta carbon. So this compound is known as alpha beta unsaturated ester or the alpha beta unsaturated carbonyl compound. Now let's talk about the nucleophile. When such type of electrophiles takes place in the reaction, then the reaction path of the nucleophile depends upon the nature of the nucleophile. Here is the question, friends. What are the nature of the nucleophile? To determine the nature of the nucleophile, there is a one theory, hard and soft acid-base theory. Here HSAB theory works. According to HSAB theory, hard nucleophile prefers to bind with hard center and soft nucleophile prefer to bind with soft center. Here hard means molecules, atoms or ions, small in size and less polarizable. Soft means molecules, atoms or ions, large in size and highly polarizable. So according to theory, there are two types of the nucleophile, hard and soft. If our nucleophile is hard in nature, then it will follow 1-2 direct addition path. And if our nucleophile is soft in nature, then it will follow 1-4 direct addition path. Here our electrophile is a alpha beta unsaturated ester compound. It is the alpha carbon, it is the beta carbon. It is the alpha carbon, it is the beta carbon. Now if we want to give number 1, 2, 3 and 4. 1, 2, 3 and 4. Okay. Now in this 1-2 direct addition path, this nucleophile is hard and this oxygen is also hard in nature. So this hard nucleophile will attack on the second position. Electron of this pi bond will be transferred on oxygen and we get such type of compound as the product. Okay, now in this 1,4 direct addition path, this nucleophile will attack on this fourth position at beta carbon. This bond will be transferred here. Electron of this pi bond will be transferred on oxygen, and we get such type of compound as the product. So here is the product of 1,2 direct addition and 1,4 direct addition path according to types of the nucleophile. Here is the reaction of Michael addition reaction. Diethyl malonate nucleophile alpha beta unsaturated ester as an electrophile. During this reaction, this hydrogen will be removed and this bond will be transferred on this carbon, and this carbon will get negative charge. Then this compound will act as a nucleophile. Then this carbon will be act on this beta carbon of our electrophile. This bond will be transferred here. Electron of this bond will be transferred on the oxygen. This reaction occurs in the presence of base, sodium ethoxide. Here ethanol 73% solvent. With this reaction we get such type of intermediate compound. Now the protonation and the back bonding of this compound, we get our final product, monoalkylated carbonyl compound. Why this compound is known as the monoalkylated carbonyl compound? Because here a 2-alkyl carbonyl compound combines to each other and gives our final product. So this compound is known as the monoalkylated carbonyl compound. Now see a reaction mechanism of Michael addition reaction. This reaction occurs in the presence of base. So in first step, our base sodium ethoxide will be ionized into two ions, sodium ions and ethoxide ions. In second step, diethyl malonate reacts with these ethoxide ions. Here electron of this bond will be transferred on this carbon. This H plus will be react with this ethoxide ion and makes ethanol. By removing of ethanol, we get such type of nucleophile. Here this A, B and C, three are the resonance structure of nucleophile. Now the third step. Third step is the conjugate addition of electrophile and nucleophile. Here we take this structure of nucleophile and it is our electrophile, the alpha beta unsaturated ester compound. It is a alpha carbon and it is a beta carbon. In this reaction, this carbon will be react with beta carbon of electrophile. This bond will be transferred here and electron of this bond will be transferred on the oxygen, and we get such type of intermediate compound. Now the back bonding of this compound, we get such type of anion. Now the last and interesting reaction is protonation of this anion. In this protonation reaction, our removed ethanol is used as the proton donor. In first step, the ethanol will be ionized into two ions, H plus and the ethoxide ions. These ethoxide ions react with the sodium ions and make our base, sodium ethoxide. So this reaction occurs in the presence of base, and here base acts as a catalyst. Okay. Now with the protonation of this anion, we get our final product, monoalkylated carbonyl compound. Here the keto-enol tautomerism are same in our product. So it is the keto form and it is the enol form of our final product, the monoalkyl carbonyl compound. Thank you very much.